something that is super trendy right now, other than agentic AI, another big trend right now is RAG, retrieval augmented generation, where people have some large number of documents that they want to be able to search over and get natural language responses over. So let's say you've got a million documents in your company, they're all like insurance claims or something. And you can use an encoding large language model to take each of those million documents and convert them into this vector representation, which allows you then to search very rapidly for related documents. So now you're an insurance claims person. I don't know what people, I don't know what titles are in
Yeah.
insurance companies. I don't know why I went into insurance. I don't know anything about it.
Yeah.
But you're an insurance company employee and you want to like you have this new claim come in and you kind of want to look at similar claims to that one. So you can use retrieval augmented generation to say, here's a question I have, or here's a claim that I have. How does this relate to previous claims that we've dealt with in the past? And that new claim that you have, or that new natural language inquiry that the insurance company employee has, is in real time, very rapidly, in hundreds of milliseconds, converted into a vector representation as well. And then you can do really simple, fast math. And there's tricks to have this work over very large spaces, even if you have billions or trillions of documents. And you bring back the most relevant documents. So let's say in that insurance company example, we had a million. There's maybe 6 documents that are determined to be closely related in semantic meaning, and the natural language is similar to the user's query. Those 6 documents come back, and then we can use all of those 6 documents as context to a large language model that can come up with a great answer based on that. So, retrieval augmented generation is linking together a bunch of different technologies, encoding LLMs, generative large language models, in order to be able to give potentially great insights over vast amounts of documents that a human could never, look over manually, and that doing keyword searches would miss a lot of information in. So RAG, very cool, very powerful. But so, what are some kinds of insights or pain points in RAG, in retrieval augmented generation? It sounds like from some research we did on past interviews you did that RAG itself was part of what led you to pivot towards developing BAML.
Yeah. So we actually started off like heavily indexing on the RAG pipelines. Um, as like kind of the original journey that we started as one of our 13 pivots. Um, and the reason that we really moved away into the more general world of just using LLMs is the thing that makes RAG really good is really high quality data. And one element of really high quality data that you touched on was this ability to pull the relevant documents. And that's just a thing that someone just has to do. You can't really help them with it. It's very data dependent, which is kind of why we moved away from it, because we don't believe that there's a general RAG solution for everything. Just like there's no general web component for the perfect accordion everywhere. You have to use ShadCN and build your own accordion that matches your theme and your styles. One element of RAG that not a lot of people think about is really around this idea of how you actually put the context into the prompt itself. So imagine if I was saying like and between every other sentence. You guys would immediately tune out. This would not be a fun podcast and conversation to listen to. But whenever you add a bunch of JSON blobs, for example, as context into your prompt, you're doing the same thing. You're putting a lot of things that the model doesn't care about. You're putting a bunch of quotation marks, you're putting a bunch of escape characters, a bunch of colons. And that doesn't actually make the prompt easier for the model to read. It just makes it possible for you to run JSON.parse on it. And those are likes and ums that the model has to go remove. If you put an image into the prompt, the way that you orient the image, the sizing that you use, the even like the text you put around the image to help it understand what the context of the image is, whether you put it above or below the image, matters. And these are things we found not a lot of people pay attention to. But with BAML, we kind of made it obvious what you're doing and where you're doing it. And we made it possible to detect these likes and ums. Because right in VS Code, like you do in Markdown files, you can see what the Markdown file renders as. We actually show you what the prompt renders as with the images, with the audio, as you're typing. So you can find these likes and ums and actually be like, oh, that looks ugly to me. That probably means it's ugly to the model, which probably means it's hard for the model to understand because these models are trained on human data.
All right. So, in addition to RAG, another kind of common thing that happens, in addition to likes and ums, those kinds of uh, verbally meaningless things that can end up being in a prompt, in addition to those which are relatively innocuous, they're like a benign tumor. There are also malignant tumors in ambiguity and errors. So, how does BAML handle instances where input data might lead to ambiguous or incorrect outputs? How does this capability improve reliability in AI driven applications?
Yeah, I think that's where I think the syntax really shines a lot. Because the problem with English is that it's a really, really poor language for actually describing what you want. It's amazing for rapid, fluid conversation like we're having right now. It's horrible for written instructions. If you've ever given someone like a 20-page list of like 20 bullet point list of instructions of things you want them to follow, they will mess up on one of them. And they do it for a couple of reasons. One, because you probably have some contradictions in there just naturally by having written them out. And you're relying on the user's inference to know which ones are relevant to your context. And the more informed they are with you, the better they'll do at it. But what we do is we said every prompt is really just a function. A function takes in parameters, and every parameter is type safe. So it's not a message, it's a message that is a class that has a role and a content. It's not an invoice, it's actually an invoice and all the parameters that exist in it. So it's strongly typed. And every function has to describe what it's going to return. So if you're going to return a bunch of categories, you're returning enum, which has a specific set of categories that are described. And instead of injecting your prompt as a giant string, you actually break down your prompt into semantically meaningful chunks. So in the case of like, let's say that insurance example you're talking about earlier, you might want to process your insurance company might be processing millions of different types of documents. One of those documents might be a new claim. One of those might be an update to an existing claim. And one of those might be just a regular like new customer inbound. Instead of describing all those rules in the core prompt, which is in English, you would actually attach a description next to each one of those categories in the enum. So now your code becomes more readable. And to understand what it means to be a new customer inbound, you only have to read that one section of the prompt. And that natively makes you write shorter prompts and almost makes you write your prompts like code, but with the flexibility of English. And I think that gives a balance of both worlds, where we want these prompts to be able to do anything, but we also don't want a 2-page essay that no one ends up reading actually over time, and we just keep adding to it, and eventually realize we have a list of contradictions, and no wonder the model's been behaving poorly the whole time for the last 6 months.